Hello everyone, today we are going to solve the Leetcode question number 54 spiral matrix. Given an m cross n matrix, return all elements of the matrix in spiral order. We are given a matrix here which is of list of list. The first row has the value 1, 2, 3, the second row has the value 4, 5, 6 and the third row has the value 7, 8, 9. If you return the matrix in spiral order, it will be 1, 2, 3, 6, 9, 8, 7, 4, 5. And we are given another example here which has 3 rows and each row has 4 elements. If you return the matrix in spiral order, it will be 1, 2, 3, 4, 8, 12, 11, 10, 9, 5, 6, 7. We have to return this as our output. I hope the question is clear. Now let's see how we can solve this problem. Here is the matrix which was given in the example, which has 3 rows and 3 columns. Here are the index positions of the matrix. As we all know, the Python index starts from 0. So the first row has the index position 0, 1 and 2. Similarly, the first column has the index position 0 followed by 1 and 2. Now we are going to declare 4 pointers. One pointer at the first row which is called top pointer. The second pointer on the last row which is bottom pointer. The third pointer on the first column which is left pointer. And the fourth pointer on the last column which is right pointer. We will iterate through each element of the matrix until the top pointer is less than or equal to the bottom pointer and the left pointer is less than or equal to the right pointer. In this case, both the conditions are satisfied, so we will traverse through the right. First, we will traverse through the first element and we will append the element to our output list. Now we will traverse through the second element and to the third element. Once we reach the last element, we will move the top pointer to the next row. Now from the rightmost element, we will traverse down. We will append 6 to the output array and we will traverse to the next element. Once we reach the bottom element, we will shift the right pointer to the previous column. Now we will check if the top pointer is less than or equal to the bottom pointer. That means that we still have more elements to traverse. So if that condition satisfies, we will traverse to the left. We will traverse to the element 8, then to the element 7. Once we reach the element 7, we will move the bottom pointer to the previous row. Now we will check if the left pointer is less than the right pointer. That means that we still have more elements to traverse. So we will traverse to the up. We will traverse to the element 4 and we will increment the left pointer. Now the left pointer and the right pointer are in the index position 1. Now from the element 4 we will traverse to the left. Now we will increment the top pointer to the next row. Since the position of the top pointer is greater than the bottom pointer, we will exit the loop and we will return the output. I hope the approach is clear. Now let's get into the implementation. First, we will declare the output array output equal to an empty list. Now we will declare the 4 pointers top, bottom, left and right. The top pointer is set to the index position of the first row which is 0. The bottom pointer is set to the last row of the matrix which is length of matrix minus 1. The left pointer is set to the first column which is 0, and the right pointer is set to the last column, which is length of matrix of 0 minus 1. We will iterate through each element of the matrix only when top pointer is less than the bottom pointer and the left pointer is less than or equal to the right pointer, while top less than or equal to bottom and left less than or equal to right. First, we will traverse through the right. In order to traverse through the right, we have to traverse from left pointer to the right pointer. For I in range of left to right plus 1, we will append each element to the output list. Output dot append of matrix of top row to the column of index position I. Once we traverse through the right, we will increment the top pointer to 1. Top plus equals to 1. Now let's traverse through the down. Down. Here we will traverse from top to bottom. Top to bottom. We will append the element from row I to the column right. At the end, we will increment the right pointer. Now we will traverse through the left. Through the left. We can check if the top pointer is less than the bottom pointer, there are still more elements to traverse, so we will traverse to the left. Before we traverse through the left, we will check if the top pointer is less than the bottom pointer. If top less than or equal to bottom, we will indent this code. We will traverse from right pointer to the left pointer. We will traverse from right to left, so I have mentioned -1. We will append the matrix from the bottom row to the index position I column. At the end, we will decrement the bottom pointer. Bottom -1. Now, as a last step, we will traverse to the up. Let's copy this. To the up. We will traverse to the up only when the left pointer is less than or equal to the right pointer. Left less than or equal to right. We will traverse from bottom to the top. we will traverse from row of index position I to the leftmost column, left. At the end, we will increment the left pointer. Left equals to +1. Now we have finished all the traversal, so we will return the result. Return output. Let's submit it. We got an error. The issue is once we traverse down, we have to decrement the right pointer. Now let's submit it. The solution got accepted.